All right. So what I want to do is just talk about the active, passive, active scan, passive scan, full scan, API scans, and authenticated scans, all of which are mentioned in our documentation in one form or another. So let me share out my screen here, and we can kind of work through what these are. You able to see my screen here?
I am.
All right. So we've got active and passive scans, which in our documentation we refer to, but we don't actually have them as environment variables. And I think that's one of the reasons that there's a little bit of confusion with how these work. So if you look, we've got a baseline scan. It says DAST executes a baseline scan, but it won't actively attack your application, but you can also configure it for an active scan. And then down here we have a full scan, which runs an active scan. And I think that's a little the confusion. So what I wanted to just do is quickly define these. So an active scan, well, let's start with a passive scan, which is really just a spidering of your site, right?
Yeah, and specifically, so Zap, the tool that DAST depends on, is a proxy server. So that means when you set up a proxy server in your browser, if you navigate to a website, the request goes via SAP to the website, and then the response comes back via SAP to your browser, and it would show on the page. A passive scan, all it means is that as Zap handles that request and response on the way through, it reads the headers and the URL and the bodies and runs vulnerability rules against them to work out if there's any vulnerabilities. So it's passively trying to find vulnerabilities. That's why Zap call it a passive scan.
So Zap basically sits in the middle, and it just looks at the requests that are going through. It doesn't do anything with the requests. It just analyzes them. It's very hands-off. It's saying, okay, I'm seeing the traffic go through. I see what it's doing. Here's the problems I see with it. I'm just going to pass that traffic through. I'm not going to do anything with it.
Yeah, so it's passively scanning. Now, Zap offer a Zap baseline script, which helps users passively scan. And that actually does more than passively scan it. It actually spiders your website too. So it basically goes and loads a web page, finds all the links, follows all the links, loads those web page, follows those links, etc. And while it's following those links, it's obviously doing the passive scanning. And that's called a Zap baseline scan.
Okay, so maybe a better definition of passive is actually just sitting in the middle and looking at the results. Passive, the baseline is what is actually including the spidering.
Correct.
Okay, so passive is just sitting in the middle, looking at the results and doing some analysis. It's not necessarily responsible for generating the new URLs or figuring out what URLs need to be scanned.
Yeah, I consider the whole spidering or using the Ajax spider or parsing an API definition to be kind of discovering the attack surface of your website. The baseline scan discovers the attack surface, and in doing so passively scans what it finds.
Okay. And I think what's important with the Zap baseline is that it's not, so it just discovers the attack surface, but it's not doing anything malicious.
I would actually disagree with that, because typically when we talk about HTTP requests being safe, as an example, we typically mean they're doing requests that won't change state on the server side, and that typically limits them to operations like GET methods on a HTTP when making HTTP requests. The thing about the Zap is the attack surface, or finding the attack surface, also makes post requests to forms.
Okay.
Makes it unsafe. So I think on our documentation, we actually mentioned that it's, you should only do a passive, or don't do an active scan on production website. I would actually say don't do any scan on a production website.
Okay. So the baseline can actually, can post data?
I believe so, yeah.
So it has the potential of being malicious. I think the goal is that it's not aggressive, but what you're saying is it does have the potential of causing problems.
Yeah, certainly its goal isn't to be malicious, but it
Right.
can cause problems.
Okay. And then tell me a little bit how you would define an active scan versus a passive scan here.
So once the attack surface has been discovered, an active scan introduces more vulnerability definitions that for each URL and method discovered in the attack surface, they will target and maliciously try and break or discover vulnerabilities against that URL. So, for example, the path traversal might take the URL and then deliberately chunk parts of the URL off and try and make requests to find access to things that they shouldn't have otherwise been able to access.
So it's going to actually manipulate the request in a way that the spider did not intend, right? So a spider is going to pass in URL parameter strings or whatever that it found on a page. And the active scan is going to say, hey, I see what those variables are. I'm going to actually change those, and I'm going to try to be bad with those.
Yeah, and which means it actually makes new requests.
Okay.
So whereas a passive scan will just, it will just pass on the requests you have made, an active scan will say, oh, I see you've made this request. I'm going to actually try and break that even further by making 100 more requests, each changing the parameters and seeing what I can break.
Okay.
And
perfect.
You can configure the active scan to work out, whether you want to do this at a medium kind of level or at an insane kind of level. And that reflects how many more requests you want to make.
Configurable to determine the level of requests / manipulation.
That's right.
All right.
That's my understanding anyway.
Cool. And then, so these are built in, active and passive scan concepts are built into Zap, and they have a set of rules that are associated with each of those. So, and we can take a look at the code shortly. Like it loads in a set of rules for active, or it loads in a set of rules for passive. Now, Zap by itself does not have a concept of a full scan. A full scan is actually, I think, kind of a GitLab nomenclature. When you run a full scan, according to our documentation, right here, so you say DAST full scan enabled. If we go back here, what is that doing? Is it running active? Is it running passive? What parameters is it using?
It's essentially doing everything the Zap baseline scan does. So it tries to determine the attack surface. In doing so, it does a passive scan. And then on top of that, it then triggers an active scan.
Okay, perfect.
So it does that based on the URLs it found in the attack.
So if you're not running a full scan in GitLab, you're running a baseline scan, right?
Correct.
Okay. So non-full scan is the Zap baseline.
The only exception to this is an API scan, but we'll get to that.
Yep. And then I think one of the things that's important in here is that when you run the Zap baseline, by default, it's limited to 60 seconds. And then by default, the full scan is not time limited.
What are you suggesting is limited to 60 seconds? Certainly a passive scan, a baseline scan can run longer than 60 seconds.
Yeah, so by default, so if you don't change those parameters.
But it's not. But the job won't time out after 60 seconds.
Right. But like, for example, if you just set up the scanner just out of the box, the include and then the URL, it's going to run a baseline, and that's defaulted to 60 seconds. So it's going to run for a minute and then it stops, is my understanding.
Okay, I thought otherwise, but we should figure that out.
Okay. So my understanding is it runs for 60 seconds, and that's part of my question, and we can get into this, is you basically have a baseline which runs a passive scanner for 60 seconds, or you have a full scan which runs the whole site for an indefinite period of time, and there's no spectrum unless you get into the configuration.
I suspect that 60 seconds might be limiting the time that you try and discover the attack surface.
Okay.
Which
yeah, we can.
The baseline case is spidering. But
okay.
Yeah, we'll see.
Cool. Yeah, maybe we take a look at that shortly. And then tell me a little bit about what the API scan is and how that's different from these other ones.
So, I mean, we've essentially hidden away the difference, but under the covers, it calls a different script. But the big difference is when determining the attack surface, it doesn't spider. Well, I think it tries to spider as well, but predominantly it determines the attack surface by reading an API definition using the open API specification. And then once you've got so that gives you all the URLs of your RESTful endpoint, which it then tries to, I think it spiders it so it can essentially call them using HTTP requests, which it does a passive scan while that's taking place. And then there's an opportunity to do an active scan once that is complete.
So it runs a passive scan against those URLs. And then when you say you can run an active scan, is that a parameter that you would pass into the script?
I think it is something worked out like that. Certainly, the way it was developed was so that the same variable that allows you to turn a full scan on and off will trigger an active scan when it's an API scan.
Okay, cool. And then the last item is we have authenticated scans. And my understanding of the way authenticated scans is they really apply to either the full scan or the non-full scan. And it's really not a scan itself. It's just the ability to authenticate into the website.
Yeah, so traditionally, a lot of websites have a login gateway at the start of their website. So obviously, if you ran DAST on a site like that, you would only be testing the public part of the website because DAST wouldn't be able to log in. You wouldn't be scanning any of the pages beyond the login gateway. So we're trying to allow people to log in. Now, on a typical website, most of them use JavaScript. So DAST has the ability to launch a browser, type the username and password and submit the form. It saves the cookie. And then with every following request that is made by DAST, it sends the same cookie so the website thinks you're logged in. That's one method of authentication.
And does the authentication scan, that will work for either the full scan or the non-full scan?
Correct.
Okay.
Now, for an API scan, it's different because you don't have a page where a user logs in. An API scan, typically authentication is performed using some kind of authorization token in a request header. So there's a slightly different process for authenticating API scans, but it's essentially the same thing. You're trying to give DAST access to the endpoints.
Spiders. Perfect. And so API scans, this authenticated via headers sent in.
Yeah.
Instead of the authentication fields that DAST defines.
Yep.
Perfect. Any other differences that we should talk about on these couple of scans?
Not that I'm aware of.
All right, perfect. You want to, we can stop the recording there?
Sure.